All right, so our next lesson is still on 3.1. The next concept that we need to talk about is point plotting. How do we get our equation onto the graph? So the graph is the picture of the solutions of any equation. And we're mainly going to be focusing on these linear equations right now, and then we'll talk about other types of equations. We'll graph quadratic equations, but we'll do that more so at the end of the chapter. So mainly we'll be focusing on these linear equations. So, thinking about x plus y equals 5. Notice that we have two variables. It's a linear equation in two variables now, the x variable and the y variable. So there's an x-axis and a y-axis, and we're looking for solutions, x-y solutions, that solve this equation. So a lot of times we organize these on what we call a t-table, but it's just an organized way to keep our thoughts and write down x and y values that solve this. Now I've started with this one because we can think of some things just off the top of our head that would work. That two numbers, an x and a y, that add to equal 5. You might just think of those in your head. Like, first thing that comes to my mind is 2 plus 3 is 5. So over 2, up 3, that's a coordinate that we can plot. Also, the reverse of that, 3, 2. 3 for x and 2 for y equals 5. So that's a coordinate over 3, up 2. Another thought would be 1 and 4. So over 1 on the x, up 4 on the y. And the reverse of that, 4 and 1. This is not always the case, but in our simpler example here, this is working. Over 4, up 1. You might be noticing already these dots line up nicely. That's a cool thing about a linear equation. When x is to the first and y is to the first, that makes that a linear equation, and the solutions will line up with a straight edge. So I could keep going with this and prove that to you, that everything I can think of works. So let me do just a couple more. Let's get a negative. Maybe negative, negative 1 and 6. That's one a little easier to get on the graph. Negative 1 plus 6 does add to be 5. So back 1, up 1, 2, 3, 4, 5, 6. That looks like that would work. I didn't make my graph quite big enough, but you can tell that's in line with that. Even a fraction like a half and 4 and a half, that would work. Over a half, how do you plot a half? Just kind of estimate halfway between there, and then up 1, 2, 3, 4 and a half. That looks like it falls in line. We could do decimals, we could do fractions, decimals, radicals, any real number. Actually, there's a counterpart to it. We could graph forever. The rest of our life we could think of combinations. Ones that I haven't put up here, let's do the zeros. Our kind of critical values, usually in graphing, the zeros are considered critical. They're where it crosses our axes. So 0 and 5, 0 plus 5 is 5. This is going to represent the y-intercept, where it crosses the y-axis. And this is going to be true in all of our graphing. Anytime that x is 0, you're looking at the y-intercept. So look at this, 0 for x and then up 5, that's where it crosses our y-axis, so the y-intercept. Vice versa of that would be if we have 0 on this side. So 5 for x, 0 for y, that's our x-intercept. So over 5, 0, also falling on this line. See how the points are lining up. If I had graph paper and a straight edge, it'd be even better. It'd be even more accurate, but just a sketch here. But you can see that those are the intercepts where it crosses the x-axis. Again, when y equals 0, that happens. And then where it crosses the y-axis when x is 0. So I could keep plotting, like I said, the rest of my life, coming up with combinations. Like, it'd be hard to graph, but let's say I had negative 100 and 105. That's a solution. When x is negative 100 and y is 105, that adds to equal 5. It solves the original equation. It just doesn't fit very well on my graph paper. But if I went back 100 places, drew this big enough, and then up 105 places, it would also line up with this picture. So when we draw this in, when we draw in this line, this is just a sample of the line, but then we put arrows to show the line keeps going that way, and it keeps going that way to represent its infinity situation here. It's not stopping at these points. These are just some sample points. And when we get into this a lot, you probably won't graph 6 or 7 points. You'll probably just graph 2 or 3, just enough to get your picture going. But no, these are sample points, and there's infinite other solutions. As a matter of fact, anything could be plugged in for x. X is infinite to the left and right, and y is infinite up and down, so there's no restrictions on how many x and y points we could have here. We will see that later on as we progress through the chapter. There will be situations where the domain and range are restricted. But our linear equation is our friend. It's the easiest one because anything goes. You can just plot forever, infinite values. All right, let's try it again. Let's say, and let's get in your book on example 7. This is a linear equation rearranged for y. So we got y equals 4x minus 1. It's in a different ordering than the last example, but it still counts as linear. This x value is to the first, this y value is to the first power, therefore I know it's going to be a line again. We can find some points by point plotting. There are other methods to graphing a line that we'll talk about later, but for right now we're pretending we don't know that. We're just blindly looking for points to plot, things that will solve this. So I don't know right off the top of my head a combination that works. 4 times a number minus 1 that will equal this other number y. I don't know that, so I have to, I could think about it maybe and come up with something. But what's easier and what typically we do, we start just maybe 0, 1, and 2. Those are typical values, easy to work with values, but you could do any numbers that you want. 0 is always nice. 0, when you plug it in for x, we're going to say, well, I wonder what works when you plug in 0 for x, what y will equal. So we can solve that. 4 times 0 is 0, and 0 minus 1 is negative 1. So now I know this point, 0, negative 1, solves this equation. And you can check it out. If you plug those numbers back in, the two sides are equal. So it's a solution. I want another point, so I say y equals 4 times 1 minus 1, which is 4 minus 1, or 3. So the coordinate 1, 3 I can plot. And I can keep on this route, plugging and chugging all day long, plugging in values for x, spitting out what y would need to be. I can also plug in on the y side and find the x values, and sometimes you want to do that. Like I want to know where, I've got my y-intercept, 0 for x. What if I plug in 0 for y? I like to know the x-intercept. So I can plug in from the y side as well. So 0, it's just a little harder sometimes, but it's doable. So 0 equals 4x minus 1. We know how to solve that. We can throw the 1 across the line. Divide by the 4. And then we get x is 1/4. So that's another solution, another point we can plot. 1/4 for x, 0 for y. And again, I can do that all day long too. We could occupy our time with x, y points with this little method. There's infinite values that work for these. So let's just do one more. Let's plug in, I don't know, let's plug in 8 for y. 8 on the y side. I feel like something that comes out better than that. I already did 7. Well, anyway, let's go back to the 8. It doesn't have to come out even. It's just easier. You probably don't enjoy plotting fractions as well. So sometimes you might want to shop for a point that comes out nicely so it's easier to plot on your paper, but it doesn't have to be. So when I plug in 8, I realized I'm going to create a fraction here, but that's okay. It's not optimal though, is it? So when you solve this equation, you throw the 1 across. We're trying to solve for x. We get x is 9/4. Alright, so maybe I should have plugged in, I don't know, 11. When I think about this, I think an 11 would plug in and give me a nicer number. And again, that's, in my words, I call that shopping for a good point to plot. All of these are valid solutions, but some are just easier to plot or fit on your paper easier. But I want you to understand there's infinite solutions. So whenever I throw the 1 across the line, I have 12 equals 4x. That's a little nicer. You divide by 4, and x is 3. All right, and that's a little easier to plot, 3 and 11. All right, so now that we've got our points on our t-table, we can plot those. If one of those doesn't line up in a line, I've made a little arithmetic mistake somewhere, so these should all line up. I'm expecting that. So sketch a graph or use your graph paper and plot these points. So 0, -1 would be right here. That's its y-intercept note. Over 1 up 3. Over 2 up 7. Let's see. 1, 2, 3, 4, 5, 6, 7. 1/4 0 is about right there. Anyway, that's enough to kind of see how it's going to connect my dots. Or even 3 points, it's unlikely they would just randomly line up. So if you get 3 points that line up, you probably have checked your work enough to connect your dots. Don't forget there's arrows on it. Okay, let me give you one to try. So you may want to pause the video and think about this for a little bit and then come back in. So 2x plus 3y equals 6 is another linear, x to the first, y to the first. So I know it should graph to equal a line. I'm going to plug in my zeros to do my intercepts. Just because those are nice points, it's not required always, but when I plug in 0 for x, I get 2 times 0 plus 3y equals 6. Again, I'm doing them one at a time. So I'm plugging in x is 0 and getting the y-intercept, which doesn't always come out to be an even integer number. Sometimes we get fractions. But this one came out nicely to be 2. So there's 1 point I can plot as a solution. Now I could just continue to plug in 1, 2, 3, whatever you feel like. But I'm going to try to find my 2 intercepts first. So I'm going to plug in 0 for y. So over on this side, 2x plus 3 times 0 equals 6. That will give me 2x. That cancels, equals 6. X is 3. So that is my x-intercept. And now if I'm feeling real confident, I could just take those 2 points and graph those. But we always recommend in math that you do at least 1 more point. So I'm going to plug in 1 for x, 2 times 1 plus 3y, and that's just random. And plug in anything you want for these. And then equation solving. Oh, I'll get a fraction. But that's okay. I said that happens sometimes. 4/3. It's just a little hard to plot. But it's just kind of a test point for me anyway. So that'll be all right. So let's plot those 3 points on our graph. 0, 2 is here. 3, 0 is here. Then over 1, and that would be 1 1/3, so just a little more than 1. That kind of verifies that it looks like I did that correctly. And then I know there are points on and on and on that we could plot, but those are our sample points to draw our line. Now, in this section, not everything is linear. We are learning about just the randomness of plotting points and trying to discover the picture, and then we'll talk more specifically about it in other sections. But you have other problems such as this equation. We would ask you in your homework, say, maybe find 3 points that solve this and try to figure out what the graph looks like. Sometimes it takes more than 3 points. If it's not linear, there's maybe some curve in it, and this one definitely has a curve. We'll talk about it, like I said, more later, but know that it's not linear like the last example, so there could be something moving or turning in it. So you might have to plot more than 3 points. Just know that sometimes. But let's try our 0, 1, and 2. So 0 squared minus 4, y will equal 0 squared minus 4. There's 1 point to plot. Then plugging in the 1, 1 minus 4, there's another point. And then plugging in the 2. And I could keep doing that, plugging in 3, plugging in 4. But I probably, especially if it's not a line, I'm not sure what it looks like, plug in a few negative numbers to get some stuff on that side. And sometimes you have to keep plugging a lot of numbers in. But anyway, as I can tell, I'm going to run out of time on this segment. This one actually graphs to be a parabola. So 0, -4, 1, -3, 2, 0. And then when I plug in -1, I actually get -3 for that. So it curves back up here. So it winds up being this shape. So in 2.1, you're just trying to explore shapes, plotting and looking for the picture of the graph.